Okay, so in GitHub now, you can see my profile is my homepage. Here is my OpenGL 3D engine project repository. So you see there's a ton of stuff over here. Here is the readme.md file, which tells the user how to use this project. And here is the stuff for building manually. And here is the link for our project. And then here you can see the GitHub actions failed. And let's see, yeah. So let's starting off with the GitHub workflows page, folder. There are two YAML files, YML files over here, and this is GitHub deploy.yml. It deploys the engine to GitHub pages. What it does is it will build, and then it will install the dependencies, and then it will create an executable and link it to create an executable and push it to GitHub pages so that it can run on the browser. Yeah, and this is itch.io deployment. So what this does is it deploys the engine to itch.io. If you see here, you can go to my itch.io page, and here go to my profile, and here is the project. So here's the stuff where you can download the project, and then you will get this OSX file over here, this executable. Open it, but since I don't have developer's license, it will show that I can't open this, so I have to manually bypass it and bypass the security settings. Yeah, so I'll open it, then open. Okay, so it runs, and here's my project. So you can see it works. Yep, cool. So this is the native build. So the other build is the GitHub Actions thing I showed you just now. So this is how the GitHub Pages thing would look like. I click this, it will show me this. As of now, it's broken. I don't know how to get this thing to work, but yeah, there's nothing in the console. Yeah, sorry, I don't know how to get this to work. And .vs code folder, this one is the configuration files for VS Code. Yeah, here you can see the two executables, and here is the release files for release configuration. This one's debug. Yeah, it's the executable path, and yeah. Okay, settings.json is the IntelliSense. Yeah, it's the IntelliSense settings. Tasks.json is the commands that we run when I run this project, which in this case would be ask cmake to build this in the debug configuration. This one is for the release configuration for both of them. Yeah. So include files. So here are the header files. So you can see a bunch of .h files. .h means header files. So basically I modularized my code into these distinct files. This one is called assetloader.h. It provides the skeletal framework for texture, for asset loading. Yeah. And these .h files will have their corresponding .cpp implementations, which will be inside the source folder. And you can see here assetloader.cpp, which builds on from the assetloader.h. And what it does is, what I do here is I get the function definitions and everything, the full implementation here. So similarly for all the other files, so there's camera, entity manager, and so on. Just modularized it, and main.cpp is what we're looking is the meat of this project. And here I include all of these OpenGL related stuff, so I can use OpenGL functions in my main file. Here is imgui, which is a user interface for debugging. These are all the file includes. The .h files, I include them inside of here so I can use them and reference their functions. And here are other global variables. Here are the shader variables. And here is vectory no change. Yeah. And scripting context, which is Scripting is basically a program which helps me compile all this C++ code into JavaScript so I can execute it, JavaScript and WebAssembly so I can run it on GitHub Actions. Yeah, FPS counter here, texture loading, which just the default texture. Then here is unscripted main loop callback. Yeah, there's a lot of other stuff here as well. Here are the meshes, the mesh variables where I store my meshes into. But I think there's a bit of a problem with the road mesh because the road mesh model is a bit large, and that's why I didn't load for the native build. I'm not sure, but when I run it in VS Code, it somehow works. Not sure how this thing works, but I don't know. Here, to create the lights, point light, spotlight, create entity from the loaded meshes I've created, and here are their positions and cull mode, scale, rotation, etc. And here is the setup main loop for native and unscripted. Okay, so as I was saying, the unscripted here is because fundamentally unscripted runs differently from the way native builds work, because web does it differently. So web would require this function, unscripted main loop callback. Yeah, which I have to set in order for, because browsers do event-based calling, so I have to do it like this. Then otherwise for native builds it's just main loop callback, that's it. And then cleanup. And then here's the input callback stuff. Yeah, a lot of stuff here, I can't go through all of it now, but yeah. Okay, so cmakelist.txt. This one is the one that tells cmake how to build my project, both natively and on unscripted. So first I set cmake minimum required version to 3.16. Yeah, and then if it's unscripted, then set unscripted to true, and then do this stuff, and then my project will be called OpenGL 3D engine with languages CX with C++, CXX. And then settings, and then a bunch of conditional checks. Yeah. There's also executable, which has all the C++ files over here. Okay, and then unscripted configuration. Yeah, and this is library detection and linking stuff. A lot of stuff. Yeah. Okay. And then index.html. Index.html is the file that tells my website page how it should look like, yeah, when doing unscripted, which is the skibidi toilet loading screen you saw just now. Oh yeah, and then the resources folder. This one has the scene models, which are the OBJ and stuff, and then the shaders, which have shader source code, and then this one is Cloud Skybox. Starting from scene models. Scene models, you have various models, cone, cube, instructions panel stuff, and then here's the one I imported from characters3d.com. Yeah, so if you open these, you just see that they're called just a bunch of stuff over here. This one, yeah, this is OBJ file, which defines the geometry of the mesh. This one is the MTL file, which defines the material. Yeah, just standard OBJ stuff here. Okay, so that's pretty much it for scene models. Then for shaders, I have different shaders for different kinds of objects. I have 4 shaders in total as of now. I have the PBR shader, which is the normal shader, and then shadow fragment and vertex shaders, as well as skybox shaders and unlit shaders. So PBR is for all the normal objects which have all the lighting applied onto them. Shadow is for shadow mapping, which is responsible for shading my regions, shading the regions that are engulfed in shadows black. Skybox is just the skybox, which has no lighting, and then unlit is for light sources which emanate light, and therefore they won't have any lighting. They'll just appear the color of their light source. The main stuff is in pbr.fragment shader. You can see I receive all the stuff from the CPU. I have vertex color, text color, and stuff, and all the samplers 2D shade, all the sampler 2D textures, the albedo map, whatnot. Yeah, here's where I do all the heavy math, parallax mapping, parallax occlusion mapping here, shadow mapping, and more PBR functions, a bunch of PBR functions. Here's main, and then okay, there's a lot of stuff here. Yeah, most of this stuff I found from learnopengl.com, so that was a great resource. And vertex shader, it's actually the vertex shader that will pass into the fragment shader first. The vertex shader will receive all this geometry data and stuff, and layout location 0 is the position in which the data is bundled up in and sent over to the GPU. And here we have vertex color, we have all the position, color, text coordinates, normal, tangent by tangent for each vertex. Yeah. And the out variables will be vertex color. Out variables are the variables and textures that I pass out to the fragment shader. Yeah, TBN matrix is one of them as well. Then there are more matrices: model view, projection, normal matrix, and light space matrix. So I do a bit of calculation here to get my TBN matrix, which is needed for both normal and parallax occlusion mapping. And we need these to offset the geometry to give it more realistic textures. Yeah. Okay, so lastly, library is all the stuff, all the dependencies I have. I vendored them in here. This is asym. This one is the library asym wasm.a, which is the WebAssembly version of the libs asym the asym library. And here are the header files. There's a ton of header files here, which define the functions of asym. And so asym itself is very large, and that's what they keep telling me, but I have to vendor it here so that it will be minimally, at least that's what I think, at least as of now. Then GLAD is for OpenGL. All the OpenGL functions are in here. Yeah, a lot of stuff. And then GLFW is window creation. This one determines, this one has all the functions you need to resize, scale, full screen, exit full screen, etc. And yeah, very important as well. Then GLM is for mathematics, because GLM just means GL mathematics. It's the go-to library we all use for OpenGL, and we see a ton of stuff. There's HPV files here, and all the mathematical functions are implemented here. Because without these functions, we would not be able to do all the matrix operations and stuff. Then imgui is the user GUI. Yeah, which allows, well, it actually surprised me how easy it was to use imgui. Yeah, I was able to create a debug window, debug panel very easily. Yeah, all I had to do was add buttons and text onto the stuff. An STB image is for image importing, so it parses the image and converts them to OpenGL textures. Yeah, see here. Yeah, yes, it supports some files. HDR. Okay. Yeah. So that basically sums up my entire OpenGL 3D engine project. So if you found this helpful, click the like button. Okay, thank you.